So my first function is complete. I will defining my second function, that's about initializing the LCD. I have named that init LCD. So I will write the function definition here, void init LCD. We're not passing any value to it. So what will actually the init LCD do? It will initialize the LCD in the sense it will initialize the LCD as 2-line 5x7 matrix LCD. It will clear the display, it will turn the display on, and it will keep the cursor blinking. Very simple job that we do by sending certain commands to the LCD, and we have already discussed in previous lectures how we send commands to LCD. Here I will be creating another function exclusively for sending commands to LCD. I will call that function as LCD CMD. So the first command I will be sending it is 38 in hex. What will this command do? This will actually initialize the LCD as 2 lines. I'm writing the comments. 5x7 matrix LCD. I have not defined my LCD CMD command yet. I will be defining that later. So the next command I need to send to LCD is to clear it, and the code for that is 01. Clear display. And then the third command, LCD CMD, I will be turning the display on and keep the cursor blinking. The code for that is 0E. That's it. That completes my LCD initialization, and then I will return. Now, before proceeding to define the functions, the next function in the list, I will be first defining LCD CMD function. First, I will write the prototype for LCD CMD function that will not return any value. So void LCD CMD, but we will certainly pass a char value to it. We are certainly passing a char value to it. So now the next function I will define will be LCD CMD, void LCD CMD. Since we are passing a char value to it, we will store that value here. Maybe we will call it anything. We can call it anything. Maybe we call it data. So what we have to do in the command function? We simply have to send this data to the port 1 where LCD is connected, data pins of LCD connected. We have renamed it, if you will be remembering, we have renamed that port as LCD data. After sending into the port 0, I have to select the register. I have to select the command register that I will be doing using RS, sending 0 to RS, and then I will be sending a high to low pulse or enable signal, and that is it. So first I will send my data to the actually to port 1 that I have renamed as LCD data equal to data. Data will be sent to LCD data, that is port 1. Then I have to send RS, the RS pin of I have to select the register that I will be doing by sending either 0 or 1 to the RS pin of the LCD. RS pin I have connected to P20, and I have also renamed P20 as RSLCD. Let me check that. Yes, I have renamed it as RSLCD. So I will be sending my data RSLCD. RSLCD. Since I have to select the command register, I will be sending 0 to it. Then I will send a high to low pulse to enable pin. Enable pin I have connected to P20, and I have also renamed that as ENLCD. So how we send a high to low pulse? ENLCD equal to 1, a brief delay. Of course, delay is another function. I have to define that one also. Delay equal delay, a brief delay. I will pass a value to it, delay 1, and then enable LCD equal to 0. Then I will give some more delay for the LCD to take the effect, to actually initialize it, then or to take the effect of any particular command. Maybe delay of 100. This delay is very brief. 100 here actually is 100 maybe milliseconds, approximately 100 milliseconds. Then return. I have to write the code for delay function, void delay. It's passing, delay is always passing a value. I will store that value in a variable, maybe tim, for time. Inside the delay function, as we have already discussed previously, I will declare two variables, int I and j. Then I will write a for loop for I equal to 0, I starting from 0, I goes from 0 to the value tim, the value we have passed, and inside it I will write another loop that will run from j equal to 0 to j less than 1275 j plus plus, then return. So why I have chosen this value 1275 here? Because it actually, this loop, this inside loop, which runs 1275 times, it actually gives a delay of approximately 1 millisecond. So if I pass a value 100 to this function, so this loop will run 100 times. So we will have a delay of approximately 100 milliseconds. I have also to write the function prototype for delay, that will go here, void delay, and the name, and we are passing an integer type of value. So that's it. Now moving on to our next function. Our next function will be, we have displayed, we have already defined two functions. I have initialized the LCD, and also we have initialized the LCD. Now we have to define this function read ADC, and it will return a value that will be stored in digital data, and this is a char value. So I will write the function definition, char. I have named it as read ADC, and we are not passing any value. So what will we do here? how we actually read the data from ADC. Just listen the steps first. We make write command write pin, we send a high to low pulse to it. When we send a high to low pulse to write, LCD starts converting the data, and when it finishes the conversion, it sends a low pulse to INTR. That is, INTR becomes low, and when INT, then that means after sending the high to low pulse on right pin of ADC, we have to wait and check continuously if INTR pin is high or low. Then if it becomes low, what we have to do, we have to read the data. That we do by again making the read pin as 0. When we will make the read pin 0, the data which has already been converted to digital form and is lying inside the 8-bit register of ADC will be transferred to its output ports and subsequently transferred to microcontroller, in our case to P3, and then I will return this data to the main loop. So my first, I have to make read ADC equal to 1 because I'm not reading the data. Then I have to send a high to low pulse on write ADC equal to 1, a short delay of maybe 1 milliseconds. Then I will send low to write ADC pin, and when I will do this high to low pulse on write ADC pin, my ADC will start converting analog data to the digital data. So I will wait for it. I will wait for the INTR signal. So how I will wait? I will write a simple loop while INTR ADC, I have named it. When it is equal to 1, that means equal to 1, that means the conversion has not finished yet. So I am waiting here. Whenever when the conversion will finish, INTR ADC will be equal to 0 and I will get out of this loop. When I will get out of this loop, I will now try to read the data. That I do by sending low to ADC read. Now the data will be on my port, that is P3. I have named that as D out. So I will read the data in some variable. Maybe I have to define a variable here, char read data. I will call it read data. Read data equal to my port 3. Port 3 I have also renamed as D out. Then I will be returning this read data. Return read data. So this value I was saying will be returned to main function, that's here, and stored into digital data. So now I am passing this digital data to my another function, that is convert data, that will be converting this digital data into temperature. So I will write the code for my next function, that is convert data. That function is also returning a value, and that value is this time int convert data. We have passed a value to it, that's a char value, and maybe I will be storing it. I will give some name to it. That name, for example, will be, I can call it digital data 2, digital underscore data 2. So now how I convert the digital data to my temperature? We have already discussed that formula. You will be remembering that I have to, and then I can write everything in one step. Actually, it will be returning a value. That value will be equal to this digital data 2, or maybe I will do it in 2 steps. I will declare a variable int temperature 1, I will call it, for example. So this temperature 1 will be equal to, I have my digital data 2, digital data, if you will be remembering the formula digital data, you can check the formula. Digital data 2, I have to multiply it by 0.019, subtract a value of 0.5 from it, divide the whole by 0.0167, and to whole I have to add a value of 25. So that's my equation, and then I have to return this temp value, return temp 1. So that's it. It will be returning the temperature, and the return temperature will be stored again in the variable we have called as temp here. And then I will be calling 2 more functions, displaying this temperature on the LCD, and also changing the status of LED depending upon in which range my temperature lies. So I will be passing this temp value to both these functions. So next I have to define 2 more function disp LCD temp and LED status. Disp LED LCD temp and so my next function is, it's not returning any value, so I will write void disp LCD what I have named it, disp LCD temp. We are passing a value into it, and that value I will be storing in a variable t. So what I will do in this function, actually I will, first of all I will display the temperature on in the first line of my LCD. So before doing that, I will clear if anything is written previously on the LCD, because this function will be called again and again, and every time I have to write the new value. So I will be clearing whatever is written on the LCD. So that I will do by sending a command by LCD cmd, by calling the command function and sending it a value of 0 x 01, Then I will force my LCD, my cursor of my LCD to the first position or first line. That I do by again sending a particular command, in this case 80 in hex, to the LCD. I have already defined my LCD CMD function, and then I will start writing like this: TEMP, temperature colon some space, and then I will write my temperature degree Celsius. So I will make another function that will actually display the data, display the characters, and that function I will call LCD data. I will be defining that function later. So LCD data, first of all I will send it the char value of t, then LCD data, I will again call this function and send it a char value of e. I have to call it twice or thrice more, amp p. Thereafter I will be writing colon to it, so I will send colon, then I will be writing, then I will be actually there will be some space after it, so I will simply put some space. Then what I have to do, actually I have to display the temperature, but my temperature is usually, it is an integer, so it will be something like this 20, yeah, or 32 or 42 or 47. So I have to break its digits first. I have to break the digit at units place. Separately I have to write that to my LCD, and also I have to break the digit at tens place and separately write that to my LCD. So that I will do using modulus operator, or may also as divide operator. I will write, for example, I will create two variables, bit 1 and bit 2. I will call this the bit at the character at ones place as bit 1, and this I will call as bit 2. So I will write bit 1 equal to T, my temperature, modulus 10. So it will actually give me, this function will actually give me the character that is at units place. For example, 32 modulus 10 will return 2. Similarly, 47 modulus 10 will return 7. And then for bit 2, I can simply do a divide. I can use a divide operator, T divided by 10. So in this case 32 divided by 10, because these are integers, I will have 3. Similarly 47 divided by 10, not modulus, divided by 10 will give me a 4. So then I have to send this bit 1 and bit 2 to the LCD. First I will write the bit 2, so I will again call the function LCD data and pass it the value of bit 1, in this bit 2, I don't have to write the inverted commas here. Bit 2 and then LCD data bit 1. Of course I have to initialize these variables, so I will do them here. Int bit 1 and bit 2. So moving on. So now I have written the temperature TMP, then I have written the current temperature. Now I have to write two more characters, a degrees symbol and C. So I will be sending the ASCII value of degrees symbol LCD data. The ASCII value of degrees symbol is actually 176. Sorry. So the ASCII value of degree, it's actually 176 in decimals, or that is B0 in hex. So I will send that value LCD data 0xB0. That will actually display degrees symbol on my LCD, and then I have to display C LCD data simple C character. This was the first line of the LCD. Now I have to move to the second line of LCD. In the second line I have to write different strings depending upon what my temperature is. Maybe if my temperature is less than 30 degrees Celsius, I am writing normal. If my temperature is between 30 and 40 degrees Celsius, I will be writing heating. And if my temperature is greater than 40 degrees Celsius, I will write hot turn off. So I will create three different if statements. If my temperature T in this case is less than 30 degrees Celsius, is less than 30, so I will send data's LCD data and LCD. Basically I will write normal LCD data O and up to LCD data L. And if the temperature is between 30 and 40 degrees Celsius, if temperature T is greater than 30 and temperature is less than 40, then I have to display another string. Sorry, one thing I forgot. Before actually writing this string in the second line, I have to force my cursor to the second line of LCD. Is that clear? So before writing these if statements, I have to write a statement here, LCD CMD. I have to send a command to the LCD, and that what will be that command? Force that command will be forcing the LCD to the second line here. So the value for that is C0. C0 in hex. So after that my cursor will be here and it will be start writing from here. So now my function, second if statement, if T, that temperature is between 30 and 40 degrees Celsius, I have to display heating. So I will again say LCD data H and up to LCD data heating, last character will be G. And then the third if statement, if T greater than 40 degrees Celsius, I have to write hot and turn off. So I will send those characters LCD data starting from H again, then O, then T, then maybe full stop, then T O U R N O F F up to LCD data F, and this will be for the whole function. That actually completes my LCD display function, disp LCD temp. So let me go through my this LCD disp LCD temperature function once more. So what I am doing here, I have to display the temperature in first line, and then I have in the second line I have to display some message. So first I will be initializing two integers, bit 1 and bit 2, that I have to use later, and then I am again clearing the display. I am clearing the display and then forcing my cursor to the line 1, position 1. Then I am writing temp temperature colon and equal to. Then I have to display the actual temperature, but that temperature is in integer, so I had take the individual characters out of it, character at units place and character at tens place, that I do using modulus and divide operator. And after that I display those two characters on my LCD with a degree sign and C, and then I have three different temperature zones, and for three different temperature zones I have to display three different messages. When the temperature less than degree Celsius, I display normal. When the temperature is between 30 and 40 degrees Celsius, I display heating. And when the temperature is greater than 40 degrees Celsius, I display hot and turn off message. So now I have to actually define the LCD data function. LCD data function will be very similar to LCD CMD function we have discussed earlier. Here is LCD CMD function. The only difference in LCD data function will be that RS LCD equal to 0, the second line here. RS LCD 0 will be equal to 1, because this time we have to select the data register. I have copy paste the LCD CMD function, and I will be changing it very slightly. So I will call it LCD data function. I have already called it LCD data function, and here I will send the data to LCD data pins, and then RS of LCD will be 1. Then I will send a high to low pulse on enable with some small delay as 1. This is not T, this is 1, this delay 1 actually. Then some more delay to that for that character to actually get displayed on the LCD, then return. That's it. So we have also defined the LCD data function. The last function we need to define now is the status of LCDs, LED status function. That is also simple. I will simply write void. I have called that function as LED status. I am passing the value of temperature to it. I will store that value in the variable T again. So here I also will be having three different if statements, if blocks. If T is less than 30 degrees Celsius, less than 30, I have to do something. And if T is greater than 30 and less than, T is less than 40, I have to do something else. And then there will be third block, if T greater than 40. In that case I will be writing some more functions. Here the if block will conclude, and here the function itself will conclude. So the first block, when the temperature is less than 30 degrees Celsius, what I have to do, I have to turn on the green LED, I have named as LEDG, and turn off the red LED. So I can simply say LED green equal to 1 and LED red equal to 0. then in the second block, when the temperature is between 30 and 40 degrees Celsius, green LED should again be on. LED green should be on, but LED red should be blinking. How I will make it blink is I will send a high to it, then give some delay, then low to it, then again some delay. LED red equal to high, then delay, maybe delay of 10 microseconds. I've already created delay. Then I will turn it off, then again some delay. And then my third block, when the temperature is greater than 40 degrees Celsius, I have to turn the green LED on, off. LED green will be off and LED red will be on, and then I can write a return statement here, return. So that concludes my program. Let's recap it. Let us go through the entire program once more. I started my program by actually renaming my pins, and the renaming was actually that showed what was their function. Then I have declared some functions here, function prototypes. Then in void main I have actually called 6 functions. First function is to configure the ports as input or output, and the second function was to initialize the LCD, that's to clear the display, to make it a 2-line LCD, 5x7 matrix LCD, and other things. And then I have called 4 functions repeatedly. The first function is reading the data from ADC. It reads the data to ADC and returns the value that gets stored in digital data. Then this digital data is actually passed to another function named convert data, that actually converts this digital data into the actual temperature. And the third function takes this temperature value, whatever the temperature is, and displays it on LCD screen. In the first line it displays a string like this, temp equal to the current temperature in degrees Celsius, and in second line it actually displays a message depending on the value of the temperature, in which range my temperature lies. If the temperature is below 30 degrees Celsius, the message is normal, the message that gets displayed on LCD is normal, and if the temperature is between 30 and 40 degrees Celsius, the LCD shows a message as heating. And in the third case, when the temperature is greater than 40 degrees Celsius, the message is that it is too hot and turn off. And similarly, then I have the fourth function that actually changed the status of my LEDs, my 2 LEDs, green LED and red LED, according to the value of the temperature. So let's go through all of these functions very quickly. My first function is configure the port. It configures the ports. Some port 1 is as output port. Port 3 that is connected to the ADC. It receives the data from ADC and hence it's configured as input port. And then some pins of port 2 are output pins and some are input pins. So my second function is initializing the LCD. In initializing the LCD, I have again called one more function, that is LCD CMD. Actually, what does LCD CMD do? It actually sends commands to the LCD. So I am here calling it thrice, and I am sending 3 different commands: 38 for 2-line 5x7 matrix LCD, 01 for clearing the display screen, and 0E for turning the display on and making the cursor to blink. And then I have defined the LCD CMD function. what I do in the LCD CMD function, I send the data to LCD data, that is actually my port 1, and then I select the register RS register select. I send a 0 there, that is I select the command register. Then I send a high to low pulse on enable pin. In this way I send my commands to my LCD. And I have also, after that, I have also defined the delay function. That's very simple, we have already discussed that many times, so I will move on. Then the next function I have defined is actually reading the data from ADC. How I read the data from ADC, I make RD and WR ADC as 1. Then I send a high to low pulse on WR pin of LCD. By sending a high to low pulse to ADC, by sending a high to low pulse to ADC on its WR pin, it will start converting the analog data into digital data. Once it finishes the conversion, it will store that in one of its internal registers and send a low signal on INTR pin. So I constantly check INTR pin. If its value is 1, that means the conversion is not finished yet. So I keep on checking. Whenever the INTR pin becomes 0, I get out of this while loop and send a low pulse to RD pin of ADC. That in that way, actually, the data that has been converted from analog to digital form and is lying in one of its internal registers gets transferred to the output pins of ADC and thus to my microcontroller. So I read that data and I return that to the main function. And then there's one more function, I call it main, that's actually converting this data. I convert this data from digital data to temperature. I have already discussed that formula earlier. That formula I implement here and return this temperature to my main function again. And in main function I call my fifth function. That function is actually used to display whatever I have to display on the LCD screen. In the first line I write TEMP and then I get individual bits of the temperature. I get bit at units place and bit at ones place using modulus and divide operators, and then I print those display those bits on LCD screen. And in next line I have to write a particular string depending upon the value of the temperature. So I create 3 if blocks that actually determine in which range my temperature is. If it is less than 30 degrees Celsius, I display normal. If it is between 30 and 40 degrees Celsius, I display high temperature or high. And if it is greater than 40 degrees Celsius, I display high and turn off. And then my last function is LC. And since I have used an LCD data function here, I have defined my LCD data function. My LCD data function is similar to LCD CMD function. I send some data to LCD, but this time I select the data register so it gets displayed on my LCD. So the last function is LED status. I have to change the status of my LEDs according to the value of the temperature. If the temperature is less than 30 degrees Celsius, I turn the green LED on and red LED off. And if the temperature is between 30 and 40 degrees Celsius, my green LED is still on, but my red LED is constantly blinking. And if my temperature is greater than 40 degrees Celsius, my green LED is off and my red LED is on. That completes my program, and that completes the topic of interfacing ADCs and sensors with my 8051 microcontroller. Thank you.